Today we are going to talk about solving one-step equations using addition and subtraction. Today our goal, isolate the variable. Our goal today is to find out what that value of that variable is. So we need to be able to isolate it to make that determination. All right, so step number one in solving these equations is to put a box around your variable term. From there, we draw a line down from your equal sign. That equal sign, that line from that equal sign is going to show us a reminder that we need to keep everything balanced. All right, so step number two is to ask yourself, how can I isolate that variable? And we can do that by using inverse operations. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division, and the inverse of division is multiplication. We must remember that whatever we do to one side, you must do to the other side. Everything needs to remain balanced. That line down from that equal sign should kind of give you that tip off that you need to keep everything balanced like a scale. What you do to one side, you do to the other. Once you've gotten your solution, you will check it by substituting that solution back into the problem as the variable and confirming that your equation does make sense. So let's try a couple of problems here. All right, so we've got 4 problems to try. First of all, we've got x plus 4 equals 6. So step number 1 for us was to go ahead and box the variable term. The x is in a term all by itself. Then we have to draw a line down from that equal sign. Remember, that line is modeling that we want to keep everything balanced. Step number 2 was to ask myself, how can I isolate my variable? How can I get that x by itself? Well, to do that, I need to get rid of that plus 4. So I need to use inverse operations. To get rid of a plus 4, I'm going to subtract 4. Plus 4 minus 4 gets me 0. Those cancel out. But because I subtracted 4 on this side, I must also subtract 4 on this side. That does not cancel out, but it does get us a number. 6 minus 4 gets me 2. I bring my x down. It is now isolated, and my solution is x equals 2. Now, I'm not done because I want to make sure that I did this correctly. So I take that 2, I rewrite my equation, and I say, okay, here I determined that x is equal to 2. So I'm going to plug 2 in for x. 2 plus 4 should equal 6. All right, 2 plus 4, 6 equals 6. I have done this correctly. They match. Therefore, my solution to this equation is x equals 2. Let's try another problem. X minus 5 equals 3. Again, the first thing I do is box that variable term and draw that line. That line helps remind me to keep everything balanced. Now, I need to get that x alone, so I ask myself, how do I isolate that variable? I've got a minus 5 here, and I need to get rid of that. I do that by using the inverse of subtracting 5. The inverse to subtracting 5 would be adding 5. Now, minus 5 plus 5 cancels out, but I still need to take that plus 5 and balance my equation. From here, I'm left with only x on this side. 3 plus 5 on the right gets me 8. Now, I think that's my solution, but I must check my work. So I rewrite my equation, x minus 5 equals 3, and I take that x and substitute it in. I take that 8 and substitute it in for x. Now, 8 minus 5, that equals 3. 3 equals 3, so I have done this correctly. 8 is my solution for x. All right, let's try 2 more problems. We've got x plus 3 equals 16. Again, we start by boxing that variable term, drawing that line down from the equal sign. From here, I need to ask myself how I isolate that x, and I need to do that by getting rid of that plus 3. I do that by subtracting 3. I must subtract 3 on both sides. Plus 3 minus 3 cancel each other out. I'm left with only an x on this side. And then I need to solve. 16 minus 3 is 13. So I believe that my solution is x equals 13, but I must prove it. X plus 3 equals 16. I substitute 13 in for x. Is 13 plus 3 equal to 16? It sure is. Therefore, my solution is x equals 13. I've got one more example here, and this one looks slightly different because my variable is on the other side of my equal sign. However, it doesn't matter. I still solve this the same way. I box my variable term and draw a line down from my equal sign. Now, I go ahead and ask myself, step number 2, how do I get the x alone? How do I isolate it? I need to use inverse operations. The inverse of subtracting 4 is adding 4. Those cancel each other out, but I need to make sure I stay balanced, so I bring that plus 4 to the other side as well. Now, here is the one spot that you need to pay extra close attention to when you have the variable on the other side. We want to make sure that that x stays over here. Otherwise, things get a little bit messy, and we don't want the mess. So if the x is on the right side of your equal sign, you keep it on the right side of the equal sign. Bring my equal, 12 plus 4 equals 16. Let's check our work. We substitute in 16 for x. 16 minus 4 is 12. Therefore, my solution is correct. Now, let's say I accidentally got the incorrect solution. So somehow this ended up being 20 or something. I don't know, something else instead. And these didn't match. That's okay. What that tells me is I need to go back to my equation and check my work here. This is my solution. This is what I'm looking for. But this is proof. This is evidence for myself and for you to make sure we've done the correct work.